Hello everyone, my name is Alfredo Valenzuela and today I'll introduce to you our project titled Development of a Mobile App to Enable Local Update and Mapping API Construction Sites Monitoring through Digital Twin. This work was completed at the MEIC lab at SUNY Korea and was also published on the Digital Twins in the Industry 4.0 special issue of the MDPI Electronics Journal. Construction sites are constantly evolving, yet the satellite imagery in tools like Google Maps only update every 4 years. If we take into consideration how dynamic these environments are and how important it is for construction inspections, um, it was in our motivation to leverage the knowledge of on-site inspectors and the schedule of time for path planning to be capable of introducing a new tool that would allow them to capitalize this change of construction sites and in real time enable path planning for UGVs or UAVs. Um, the main focus or the main focus of our app revolves around homography, a computer vision method that maps points between two planes, allowing us to rotate, translate, scale, shear, and transform an angled photo into top-down perspective to be capable of being used in Google Maps. After computing the homography, we determined the minimum cropping distance to create a rectangle around our region, our image of interest. Ensure that we are discarding all of the empty pixels, or also known as zero value pixels. If any appear in this case, then we would have to generate a PNG image. Here's an example of an angled image taken from Google Maps API and used homography and then cropping to generate an image capable of being overlaid on our app. The system overview for this app is as follows. The user will have to upload two images. One is generated through a screenshot from the Maps API, and the other one is the most updated scene from the site in their gallery. Then the homography will be computed by selecting 4 corners on each photo that is enclosed in the site. And through geolocation information, we'll be capable of scaling this image to the real size of the construction site and also be capable of overlaying it through a pivot utilizing the Harrison equation. Once this image is overlaid, the user is capable of drawing around the image any path, and this path will be projected on Google Maps to obtain those latitude and longitude points, then converted to Mercator and sent to the UGV so that it can navigate the desired path. To validate our pipeline, we used a soccer field of 60 by 95 meters as a stand-in for a construction site. Its straight lines made corner selection easy for testing homography accuracy. We also utilize a AVD or Android virtual device with an Android API of 33 with a phone model of Pixel 3. This will ensure that this mobile application can be utilized in very low spec phones and anybody can have access to it. So our mobile application has the following functions. First, we have the overlay function, which superimposes the correct image on Google Maps. We have the geolocation function, which pins the device's GPS information to be capable of overlaying it. We have the screenshot function, which allows us to get the satellite view of the current view of Google Maps of the construction site. We then have the corner selection function, which allows us to input both images and select the corners for the homography to happen. And finally, we have the coordinate sending function, which, based on the map, on the drawing, the path that we've drawn, it'll compute the latitude and longitude points to be sent to the UGV. To quantify accuracy, we developed a MATLAB script taking into consideration this following sites. With this following sites, we want to be capable of computing two metrics, which are the distorted area and the distance between points. The area of distortion would be the percentage change in the polygon area, and the corner of error computes the distance between true and computed corner selection. For our first site, we have the overlaid image versus the actual Google Maps image. And in here, we can see that there was around an 8%, under an 8% of distortion, as well as an offset of around 1 meter for the mean error in the entire area of the construction site. For the second side, we also have distortion under the 10%, and we have a mean error of 1 meter again. Finally, for our third side, we do have an increase of error for our area distortion and corner selection. However, this can be due to multiple issues such as the selection of the corners done by the user. In summary, our app empowers inspectors to generate a real-time top-view map of any site using just a smartphone. By computing homography on the fly and projecting user-defined paths into UTM, we enable construction managers to plan UGV routes and inspections with up-to-date information.